All right. So again, this is up to number 12 notes wise for today. We're doing 3x3 systems. And again, the 3x3 basically means that it's three equations with three variables. Okay. And with these, because everything we're doing before was ordered pairs, because we had X and Y. In this case, it's going to be ordered triples that we're looking for, and it should either be X, Y, Z. They may throw in a couple of A, B, C's, but it should be three letters in a row. Again, most of the time we do X, Y. A lot of times the triples, they'll do X, Y, Z. They may throw in an A, B, C, but it's still the same thing no matter what letters they put in there when they go through this thing. All right. Now, one thing they probably will do is, and we'll do this on the next one we've got here in a little bit, but let's give you the steps first, and then we'll kind of go from here. Um, actually, we'll do this. Actually, let's change gears from this one. So let's do X minus Y plus Z equals -1. Maybe it's X plus Y plus 3Z equals -3. And then 2X minus Y plus 2Z equals 0. All right. And one of the very first things that's going to happen is they're going to give you a systems of equations, and they're going to ask you for something like this, and they're going to ask you, is this ordered triple a solution to the problem? So maybe something like this. Um, and we'll wind up actually doing a couple of these in this part when it comes down to it. But so here's the problem. So they give you this ordered triple, not an ordered pair, and they'll ask you, is this ordered pair or ordered triple a solution as you're going through this thing? And all you have to do is basically just take this thing back in, and again, this is your X and your Y and your Z, and plug it back into, and we'll go over here on the side and label these equations just to make it easier. You're going to plug this back into equation 1 and see if it makes it true. If it makes it true, you go on to the next one and see if it makes this one true. If it makes this one true, you go to the next one and see if it makes it true. And if this makes each equation true, then it's a solution for what you're looking for. If any one of the equations that you plug it into is false or doesn't make any sense, then it's not going to be a solution. Okay, and I think there should have been one probably mixed in with some of those with some ordered pairs, and that may have been, it might have been a little while back in the homework. But anyway, they should have kind of done the same thing with ordered pairs with the 2x2 system. So, okay, so again, what we're going to do, we'll plug it into equation 1 first and see what happens. So that's 1 minus 2 plus 3. And the question is, does that equal -1? So does -1 plus 3 equal -1? Nope. So if they ask you, is that a solution? There you go. It's not. All right. And again, for it to actually be a solution, this equation would have to be true. This equation would have to be true. And this equation would have to be true for each part of it. And again, if any one of the three is no, then you stop and then you say, all right, it's not a solution. So you have to go through each problem and go through that. So if you plug in the first one, let's see what happened here. If we had plugged into the first equation, let's say we plugged this in and we had 8 equals, or actually it'd been like -1 equals -1. If that part had been true, then we would have gone to the second equation and plug it back in. If that one's true, then we go to the third one. And if it's true and all three parts are true, then it is a solution. And again, if any one of them is not a solution, if you get to a point where it's like this and it doesn't make any sense, you stop and there's no need of checking. There's no need for us to check 2 and 3 because if it doesn't work here, it doesn't matter what it does here. It's got to fit all 3 to make it about to be a solution. Okay, so there's some where they'll just give you a number and you plug it back in and just see what happens as you go through those. All right, now what we're going to do though, here's the steps to actually solve as we're going through this, because you may get maybe one problem like that, maybe two, to kind of just to plug in some numbers and work with the order of operation stuff. But to actually solve, all right. So what we're going to do is we're going to solve a 3 by 3 system. You're going to eliminate one variable from 2 equations. All right. If we do that, we're going to call that like new equation 1. Okay. And then the second thing that we're going to do after that is, and this is the part sometimes that people kind of forget and do wrong, throw things off. You're going to eliminate the same variable using a different pair of equations. Okay, so eliminate one variable used from 2 equations. And the key thing on that one is because this, if you do this, then you're going to be okay. Where people get lost on this one is one time up here they'll eliminate x, then they'll eliminate y, and then they put the 2 together, and then they go, well, it doesn't make any sense. I'm like, well, no, because you got to kind of pay attention on that one. That basically this becomes like new equation 2. Okay, so we've gone basically if we do those first 2 steps, and again, it's the same thing, just kind of going through that one. Now you've got 2 equations, but instead of having 3 variables, you're down to 2 variables, and that puts us just like the work we were doing the last couple of days. If you do this one now, you're going to use the 2 new equations. And then you're going to solve by elimination or by substitution. Okay. Now, where is everybody kind of feeling? Is everybody thinking more elimination, or is everybody thinking more substitution at this point? Elimination? Okay. And again, usually as far as the setup of it goes, elimination, at least in my mind, from what I've talked to and everybody in the years past, usually about 95% of people like to do elimination. So that's what we'll kind of stick with. There's usually, there's always a couple of weirdos in the classroom that want to do substitution. Don't know why, but Alan. Alan. So, if you're a substitution person, we're probably going to, go more elimination route to kind of get through this one. But all right, and then once you solve this equation, find out what variable you're going to have, then you just go back and then, so step 4 is you've got to use, now at the end of it, once you figure out what these 2 variables are, probably by elimination, you've still got to go back and take those values and plug them back in to find all the values. So whether we like it or not, at the end, we're going to have to go back and do substitution to find all 3 values. But that's really the easy part, because once you've got x equals and you plug it back in and you find y, well, now you've got x and y. You can take those two numbers and plug them back in and find z. So, step 4 is really pretty easy. The big thing on this one is getting through these first two steps where you're going to eliminate one variable, but then you have to eliminate the same variable using a different pair of equations, so that you now got a 2 by 2 system, like we were doing in the homework, like we were doing with the graphing, like we've kind of been doing everything up to this point. Okay, and what we're going to do is we're going to go back to this problem I had back up here where we're checking to see if this was a solution. So we're going to basically just take that problem and kind of rework it from there. All right, everybody get on the steps? Everybody got them written in? We'll pause for a minute if we need to. Okay, so again, what we're going to do, just going to go back to that original set we had here and just write down all three of those equations. Okay, now here's the thing. When you're going through this, when we're going back to our first two steps, when you pick a variable to eliminate, there is no wrong variable to eliminate. However, there is usually, I wouldn't say a worse option, but there are some options that will make you do more work than you have to do. So what I always tell people is you want to kind of, just like when we're doing substitution, how you look for the ones that always had just the coefficient of 1, where it basically just had like an x. You want to try to get it so that the numbers are as close matched up as you can. So like this one, you've got 1x and 1x here. X's wouldn't be too bad of an option. With the z's, you got 1z, 2z, 3z, which means you're going to have to kind of multiply this equation by 3 to eliminate this one. Then if you work down here, you'd have to multiply this one by 2 to eliminate this one. But if you kind of notice the numbers, the way this is set up, you've got a plus and minus y here that if you put these two together, this y goes away and you don't have to do anything to it. You can also get rid of a plus and minus y here to eliminate this y. So to me, it seems like that probably for that particular problem, the best thing to do is we're going to eliminate y twice. And again, there's no wrong way to do it. Well, there are, but there's no wrong variable to pick which one you're going to eliminate first. So it doesn't matter whether it's X or Y or Z. You just have to kind of look at it and go, okay, I think this one's going to be the least amount of work to get through this one. And usually it's going to be the numbers that are closest to each other. Like this one's 1, 1, and 1. Well, that makes it really easy because they're all ones. This one's 1, 2, and 3. So they're a little bit more spread out. This one's 1, 1, and 2. So if you look at just the numbers of it, this is going to be your easiest one. This is probably going to be the next one that's easiest. And if you got rid of Z's, it's probably going to be the most amount of work just because the numbers are kind of spread out there. Okay, so we're going to just go ahead and do equation 1 and equation 2. Because if we put those two things together, we've got x minus y plus z equals -1, and x plus y plus 3z equals -3. Okay. And when we go through this one, you know where most people will miss this problem? At the beginning, they'll tell me x plus x is x. Because they'll kind of get in a hurry. They're looking at other stuff. Remember, technically, that's 1x plus 1x. So that is really has to be 2x. So again, if it's for some of y'all that's been a year that you've kind of forgotten these, everywhere you've got a variable that's just a variable by itself, it probably wouldn't hurt to go back and put a 1 there till you get comfortable that you know that that 1 is there. Kind of thinking about it that way. So then you've got -1 plus 1, so that goes away. So that's what we want. You've got 1z plus 3z, that would be 4z. And then -1 minus 3 is -4. Okay, so this is our new equation 1. Okay. All right, and again, the catch on this one is now we've got to eliminate y again, but you've got to use a different pair of equations. So we cannot use 1 and 2. So we can either use 1 and 3 or we can use 2 and 3. For this one, I'm going to pick 2 and 3 because this one's already positive and this one's already negative. So for the second time, I'm going to do equation 2 plus equation 3 because if I do that, I don't have to change any signs. So that's going to be x plus y plus 3z equals -3, and 2x minus y plus 2z equals 0. Okay. And again, it's a small thing, but go back and put, I would say just to be on the safe side, just go back and put some 1s there. So it's 1x plus 2x, make that 3x. That's 1 minus 1, so that's 0. That's what we want. It's gone. It's 3z plus 5z. Sorry, 3z plus 2z. That is 5z, and -3 and 0 is in -3. And that's our new equation 2. Okay. And it may actually help for you to write down what you're doing because sometimes people, again, they'll look at this one and they'll go, oh, I'll just get rid of y over here. And they'll get this one, they'll go, oh, and I'll eliminate x here. Well, then they put them together and it's back to the same thing. You've still got 3 variables, and that doesn't really do a lot. So once you've got x or y gone from this one and y gone from this one, put these two things together. And now we're going to solve this equation with these using these two new equations. We're going to solve that just like we've been doing the last, well, we did examples one day, did the homework next day. So basically the last couple of days. And again, you can go elimination, you can go substitution. It doesn't matter. You just pick whichever one you think is best. And again, most people are probably going to say elimination, so we're going to stick with elimination here. There's no easy multiples here. So we said if there's no multiple to go from 4 to 5, there's nothing you can multiply to go from 2 to 3. So if that's the case, we're just going to swap these two numbers. We're going to multiply by 3 here and multiply by 2 here. And if we do that, we get 6x plus 4z equals, oh, nope, hang on. That's 6x plus 12z. And then 3 times -4 is -12. All right, on the bottom one, if we multiply by 2, we've got 2 times 3, that's going to be 6x, right? But we said if this one's positive, this one's got to be negative. So to make that one negative, we just got to multiply by -2. So we've got -6, we've got a minus 10z, and a positive 6. All right, and then we've got 6 minus 6 for 0. That's what we want. That one is gone. We've got 12 minus 10. That is 2z. -12 plus 6, or 6 minus 12 will make that -6. So z is -3. Okay. And again, now we're right back in the same boat we've been. Now you pick this, and you can go back to, now before we get back to the originals, we're going to go back to either one of these two new equations we have and take that z equals -3 and plug it back into either one of these two new equations. Doesn't really matter. Just pick one. I'm just going to go with the first one. We're going with 2x plus 4z equals negative 4. I should know here. Right there. So we're going to plug in the negative 3 back into this equation we're working with here. So that is 2x plus 4 times negative 3 equals negative 4. So that's 2x minus 12 equals negative 4. Adding our 12 to both sides. We've got 2x equals 8. And we get x equals 4. Okay, and now you've got these two. You've got an x and you've got the z. So now you've got to take these two parts we've got here and take those numbers and plug them back into any one of these original equations so we can figure out what the y is, because we've eliminated y here, so there's nothing we can do with it. So we're going to have to go back to the beginning. All right, and again, it doesn't matter which one you pick. Just pick one that you think is the easiest. If you don't like negatives, then you may look at this and go, all right, I'm going to pick this one because I've got x plus y plus 3z equals negative 3. Somebody may look at this one and go, well, this is equal to 0, so I'm going to go here. It doesn't matter. You just pick one of these three equations and plug it back in. So we got x plus y plus 3z equals negative 3. We're going to plug in the x equals 4. And then z equals negative 3. So once you've got this system solved and we've got the 4 and the negative 3, you can take those two values and plug it back into the original just to see what you got. Okay, so we've got x is 4. We don't know what y is. Z was negative 3. And that's going to equal negative 3. All right, so that's 4 plus y minus 9 equals negative 3. And again, you can do this in a couple of different ways. That if you just think about rearranging this, that's y plus 4 minus 9 equals negative 3. And if we do 4 minus 9, that is y minus 5 equals negative 3. Add 5 to both sides, so then we wind up with y equals 2. Okay, so final answer is, again, it's got to be an ordered triple. So if we go x, y, z, that's going to be our final answer. Okay, so everybody all right there? Everybody's okay? All right, so let's do another few of these, just kind of see how it goes. So let's go 3x plus y minus z equals 1. We'll go x plus 2y plus z equals 4, and 3x minus y minus z equals 3. Okay, so again, it comes down to which one do you think is going to be the easiest one to go with here? Again, there's no right or wrong answer because if you look at this one, you've got a positive y and a negative y here, so that would eliminate pretty easy. Then you can multiply this one times -2, and that would go with the x's. You can multiply this one by -1, and those would combine out. Then you can multiply this one by -3 and put that one here. But again, this one's already got a plus and minus z here, and a plus and minus z there. So if you're going with the one that's the easiest, we're going to eliminate z twice. All right, and that seems like a little thing to write it down, but here's my suggestion when you do these. The 3x3s, write down and actually write it down and tell yourself to eliminate z twice. Because if you will tell yourself that, then it's less likely you'll do z one time and x another time. Sometimes you tell yourself to do something, you'll do it, and not just actually like write it down so you got it there. All right, so let's go equation 1 plus equation 2, and let's see what we got. All right, again, little things, go back and put ones on all the variables till you get comfortable. Now, if you're comfortable with it and you don't think you'll forget those, you don't have to worry about it. But if it's been a while and you're afraid you're going to forget those, go back and put ones on all those variables. So now you've got 3x plus 1x for 4x. We've got 1 plus 2 for 3y. The z is gone. We got 5. Okay, so we eliminated z the first time. We're going to do it again. And again, to me, you can do it a couple of different ways. You just cannot use 1 and 2. You can use 1 and 3. You can use 2 and 3. You can you just cannot reuse 1 and 2 together. So for this one's positive, negative. So I'm going to go equation 2 and equation 3. All right, again, if it helps a little bit, go back and put ones everywhere where the variables are by themselves. So we've got 1x plus 3x for 4x. We've got 2 minus 1, which is 1y, which is okay if we put that. 1z minus 1z, 0. 4 plus 3 is 7. Okay, and again, the big key thing is after that first, basically I know it's one step, but it's just the same thing repeated twice. Is you've got to have the same variable gone for both. So now you should just have two equations with two variables. If not, that's to me why it's kind of big to go back and actually write down what you're going to do. If you write it down, you can kind of you can check yourself almost. Did I get rid of z twice? Well, if I got rid of it here and I didn't get it here, I need to go back and just scratch this out and start back over and make sure I eliminate the same variable twice on this thing. All right, and then pulling those two things together. We've got that. We have that for new equation 1, new equation 2. And this one works out really nice because you've got two pretty easy options on this one. You can multiply this equation by -3, so you'd have 3 and -3. But probably even the easier option is, since this is 4 and 4, let's just multiply that equation by -1. Because doing that one by -1, you've got 4 minus 4, which makes that really easy because that knocks that out. Now we've got 3 minus 1 for 2y and 5 minus 7 for -2. So then y would be -1. All right. So again, now you've got y equals -1. Just pick one of the two equations, plug it back in. I'm going to go with the 4x plus y equals 7. And then we're going to take that and plug it back in. So now we've got 4x plus 1 times -1 equals 7. So that's 4x minus 1 equals 7. We're going to add the 1 to both sides. And then we divide by the 4. So we got x equals 2. Okay, and again, now that we've got the two answers from the 2x2 system where we've done that, we're going to take the x equals 2 and we're going to take the y equals 1 and plug those back into any original. Doesn't matter which one. Just the one you think might be the easiest one to work with there. You may got a preference? Equation 1 to equation 2, equation 3? Equation 1? I think it's what I heard, so we'll go with that. So we've got 3x plus y minus z equals 1. Plug in the 2, plug in the 1, or the -1, and then just work it out from there. All right, so plugging in the 2 and plugging in the -1, again, we just picked, I think somebody said equation 1. So we'll plug it in there. That's 3 times 2 for 6. 6 plus -1 is just 6 minus 1. Minus z equals 1. This is together, so go ahead and do 6 minus 1 and make it 5. And just remember in that case, that's a positive 5. So when you get rid of it, you're going to have to go minus 5. So it's a negative z equals a -4. And again, just change the sign to make it positive. Also got to change that sign around and make it positive. Basically, we're just dividing through by -1 to get rid of that negative that's there. All right, and then so final answer. It's got to be x, y, z. So it's 2, -1, and then 4. Again, I think with Math Excel it works out pretty nice because they'll give you the 3 blanks, and it makes you go back in and plug in those 3 blanks. Kind of get there. Okay, so for the last one, we'll look at here. And again, if we've got time, we got one more we'll get to, but one of these, and then we'll see where we got time-wise. For this one, show you one that looks a little different. Because this is one that in the past has kind of freaked some people out a little bit. Okay, so for one like this, you've got some missing variables. From equation 1, we're missing z. Equation 3, we're missing y. And sometimes that throws people off, but that's actually kind of a good thing because when they do this, they've already eliminated, they've done step 1 for you. So they've eliminated y from this one, they've eliminated z from this one. That basically, they've kind of done step 1 for you. Again, they're not really missing, but the way we look at it, they're missing in that case. We'll quote unquote call them missing. So when variables are missing, step 1 is done for you. So they've already eliminated y in this one, or they've eliminated z in this one. You just have to figure out, okay, which one do I want to get rid of? Do I want to get rid of y in these 2 equations, or do I want to get rid of z in these 2 equations? And you just have to look at it and kind of go, all right, well, they've got rid of these, so do I want to get rid of y, or do I want to get rid of z? Which one do you think would be easier to get rid of in that case, the y or the z? Probably z, right? Because if you want to get rid of y here, you're going to have to multiply this one by 3 and this one by 2, where in this case, just got to multiply by 2, right? Because that way you can make this 2z, and that's already negative 2z. So for this one, since they've already eliminated z, we're just going to eliminate z from equations 2 and 3. Okay, so so whenever you see one that's missing, again, they've actually kind of helped you out, because now step one's done. You've just got to go ahead and say, all right, well, if they got rid of z here, I'm just going to get rid of z in these two, and then I'm good to go. All right, so if we do that, we said we were going to take equation 2 and multiply by 2. So that would make that 2x plus 6y plus 2z equals 0. Okay, and then we'll put it together. So we've got 2x plus 2x for 4x, 6y because there wasn't anything to put with it. The z's are gone, and that will leave us with 18. You're like, okay, well, I've got this one now, eliminated z, so what do I do next? Well, they already eliminated z for you back here in equation 1, so just put this together with equation 1. So put that together with the original equation 1, which was x minus 2y equals 1. Okay, and now we're going to solve that system. Okay, and again, it doesn't matter, just in your eyesight, which one you think would be easy to get rid of. And actually, both of them are pretty easy, because in this case, you can multiply this equation by negative 4 and get rid of the x's. You can multiply this equation by 3, and you've got 6 and a negative 6. So really, just kind of your pick of which one you want to do here. Anybody got a preference? Do you want to get rid of x, or do you want to get rid of y? Get rid of x. Okay. All right. Now, why for people that saying of the two? Here's a good discussion point, I guess. Does anybody want to say why you think x is better? Because again, there's no right or wrong answer on this one. Just trying to get some discussion thoughts on this one. Okay, so it's just okay, and some people just like it because they're like, oh, I just put a negative 4 right in front here, and it's multiplying like by the 1, so it's negative 4 times 1. It's easy to go with it there, and that's fine. The people that are talking about getting rid of y, what's your thinking on that one? Okay, multiplying by 3, right? Do you have to change any signs? No. So, and some people look at it that way. They go, well, if I multiply by 3, I don't have to change any signs. And they like it that way. Some people like the 1 in the front. They go, well, I'll just do, if this is 4, I just know I need to multiply by a negative 4. So it's just whichever one you think is easiest for you. There's no right or wrong answer on this one. It's just whatever in your eyesight kind of looks the best on that one. So for this one, now, again, I'm more of, to me, for this one, I kind of think because, and this is me speaking not from my preference. It's more of me working and seeing what people do. If the signs are already different and you don't have to multiply by a negative, more people will get this answer correct. So for this one, I'm going to take this one and get rid of the y, because I'm going to take this equation and just multiply it by 3. Because I don't have to change any signs. That, from what I've noticed in the past, when you don't have to change signs, y'all tend to do better. Well, previous teams tend to do better. So we'll kind of stick that same thing. If one's positive and negative, because they're both easy to multiply. This one's just multiplied by 3. This one's just multiplied by -4. So it's both really easy. But if you don't have to change any signs, it usually means people do a little bit better with those. So, all right. So if we do that, we've got 4x plus 6y equals 18. If you multiply everything by 3, that'll put us there. All right, so that's 7x equals 21. I heard somebody say then x equals 3. Okay, and then you can go back to either one of these equations. Now, with these equations, actually, sometimes you can go back to the originals and find problems that's easy too, because we've got, x minus 2y equals 1. We've got 4x plus 6y equals 18. Again, if you want to pick which one you want to go with here, I'm going to go back to this one, the 4x plus 6y equals 18. And we'll plug it back in there. Again, it doesn't matter if you pick this one or this one. Either one's fine. That makes it 12 plus 6y equals 18. Subtract 12. 6y equals 6, so y equals 1. Okay, and then so we've got x and y. We've got to figure out what z is. And if you go back to the original, we're going to plug these back into some original equation. So we got to go back and pick one. If you notice, this one, equation 3, only has x and z, right? So this one would, now again, you can't pick equation 1 because if you plug x and y in here, there is no z. So that's not going to work. So we're down to one of these two. Since this one only has x and z, this one's actually pretty easy to plug it back in here. And again, you can pick either one of the two and it would work. But I'm going to go back to 2x minus 2z equals 18. Because for that one, we just need that x equals 3 to go here. So that's 2 times 3 minus 2z equals 18. We're not a room here, so I'm going to bring that back over here. So it's 6 minus 2z equals 18. Subtract the 6. And then divide by the -2. All right, so final answer in order triple would be x, y, and z. Okay, now let me do this. Let me just show you, and we're not going to work all the way through this last one. Let me just show you one to start with, and y'all don't have to write this one down. Just kind of watch because we'll get through the first step of it, and after that, it's again all pretty much the same thing. But I just want to show you one that's got to make you think just a little bit more than some of the ones we had here. Again, you don't have to necessarily write this one down, but let me just kind of show you one here. Because once we've got it started, everything else kind of rolls. So we'll just get this one started, just so you can have some idea of kind of what's happening with it here. Okay, so if we start with this one. Not a whole lot different to it. Kind of the same thing on this one. The big difference is if you look at this one, you're gonna have to work around, and there's not going to be like all the other ones we had where you can just look at one and go, oh, there's a plus and minus y, and there's a plus and minus y. We can get rid of it. This one, not quite so much. You're gonna have to do some extra multiplication with this one. All right, and again, if you're looking for these, if you can find one that has a one as a coefficient, whether it's this one or this one, that's going to be your easier variable to kind of solve with. You could solve x, but there's going to be a whole lot of multiplication with that one you've got to go through. So if you have one like this, it's easier to either use to eliminate y or z. Doesn't really matter. So let's just say we're going to eliminate. Anybody got an option on that one? Which one do you think looks better? Y? Okay, we'll go with y. All right, so we're going to get rid of y in this case. We just picked 1 and 2. Doesn't matter. That basically, and here's what you want to do. Since the 1 is here kind of on this part, you're going to put these two together, and then you put these two together. So whatever this one is, it's got the variable that's got the 1 with it, with coefficient of 1. You'll use that one twice. So you use 2 with 1, and you'll use 2 with 3. So to get 1 and 2 together, to get rid of this thing, since this was already 3, we're going to have to take equation 2 and multiply by -3. So if that's a 3, this needs to be a -3. So we just need to take equation 2 and multiply by -3. So that would be -5x plus 3y plus 6z equals 4. And then taking equation 2 and multiplying by -3. And I didn't say this earlier, but when we're doing these, be really careful because these are problems that if you write down one number wrong, it will mess up the whole thing. It could be you may leave off a negative sign, or you may, if it's 14, you write a 4 instead. So on these, when you're writing down these numbers, be really careful. Don't get in a hurry, because if you get in a hurry on these, it'll mess up in a hurry, because then you'll start getting like 22 over 99 or 22 over 103, and then you're like, whoa, what is that? And then it just gets jumbled up from there. So everything we're doing, we're going to stick to pretty much whole numbers. There might be like a 0.5 in there somewhere, but everything should be whole numbers or something really close to it. All right, multiplying by -3. That makes that a 9x, a minus 3y, a minus 15z, and a positive 15. Okay, so that's 9 minus 5, so that's 4x. The y is gone. That's 6 minus 15 for -9z, and that's 19. Okay, so if we got rid of y with 1 and 2, again, we're going to reuse 2, so that means we're going to go with 2 and 3. So now we're going to take equation 2 and multiply it by -2. And then we're going to add that to equation 3. So negative, because if we make this a -2, that's a +2. Those two things will cancel. So take everything here, multiply it by -2. So that's going to be 6x minus 2y minus 10z equals 10. And we didn't change this equation 3. And let's see what we've got. So now we've got 2x. Again, don't forget there's a 1 there. Minus 9z equals 23. All right, now everything after that should be pretty standard, because now we've got this equation and this equation. We'll pull those two equations together, and then from there the math would be really easy. because the z's are almost the same. Then we would just need to take one of these equations, doesn't matter which one, multiply it by -1, and that's good to go. Okay, but again, it's just getting down to that point where you've got the same variable eliminated, because if you can eliminate that same variable twice and pull those together, that gets really easy, because that's what we've been working on the last few days, and it just kind of goes from there. Okay, and if you want, now what we'll do, because we're going to run short on time this one, if you want to finish this one out, if you want to see if you did the work correctly, I'll go ahead and give you the answer, and if you want to finish it out, you can. The final answer here would have been, let's see what this one was. Make sure I got the right number. It was -2, 4, and then -3. But again, we're going to run a little bit short on time, so just if you want to finish it out, you can, just to see if you've got it going from there. But then that should have been the final answer for XYZ.